3/20? No. 3 out of 5, 6, 12. I have 1/5.
Oh.
1/5? 12 over 120, right? No? No.
3 times 60.
Okay. 1/5? All right, the x is equal to 4. I get 3 out of 5, 2 out of 4, 1 out of 3, and then 2 out of 2. And I should get 1/10. So I add these all up, 2/5 plus 3/10 plus 1/5 plus 1/10 is 4/10 plus 3/10 plus 2/10 plus 1/10, 7, 8, 9, which is 10/10. Now it says find the probability distribution of x, which is the number of marbles removed. So the probability distribution table, if you will, it would be 1, 2, 3, 4, and then I would have, that's x, right? And the probability is 2/5, 3/10, 1/5, and 1/10. That's the way I would draw it as a probability distribution table. Okay? All right, then this other text, this commentary we talked about before. Consider the following frequency table that shows the grades on a particular test. Right, I have 150, 260, so on. We can construct a relative frequency table. 50 occurred 1/10 of the time, 90 occurred 1/10 of the time. Relative frequency refers to the number of times that particular grade appeared. Then you can find the mean 3 different ways. All right, and then I have definition 3, the expectation of a random variable x. The expected value is the mean of the set of data. So capital E of x is the mean. Given the table of values below, find the expected value of x. Now, here's what when I have a discrete probability distribution, the expected value is the sum of all the values times their probability of getting those values. I'm adding all the scores and the relative frequency, right? Do you all understand that?
Yes.
Okay, that's what you do when I multiply 50 times 1/10 plus whatever. All right, so in example 5, given the table of values, find the expected value or the mean. So I'm going to go mean, x bar is equal to. My first value is 0. How many values do I have actually? What's the frequency, some of the frequencies?
$120.
120. Right? So 0 occurred 30 out of 120 times, plus 1 occurred 20 out of 120 times. Does everyone see what I'm doing here? Everyone? Or just Maggie? Yeah?
Yeah.
Yeah? Everyone?
Yes.
Loudly?
Yeah.
Thank you. No?
What?
2 out of 36, 2 times 36 out of 120. Did you say no, X?
No. I just did that.
Oh, funny. How do you do that? No. 3 times 24 out of 120? Plus 4 times 10 out of 120. All right, so you all have your calculator out. Find that mean. What do we get? 1.7. Okay, last section of the year, ladies and gentlemen, last section of the year. Continuous probability density functions. Continuous probability density functions. When a probability table contains a large number of possible outcomes of an experiment, the associated histogram for the random variable x will look like the graph below. Since the rectangles that make up the histogram all have the same width, their areas are in the same ratio as their heights. The area of each rectangle will then give the associated probability of x. This histogram is sometimes called a probability density histogram. The probability that capital X is 5, that the random variable takes on the value 5, is the area of the rectangle at 5. The probability that the random variable takes on the value of 10 is the area of the rectangle at 10. Hopefully you know where we're leading. The probability that X lies between 5 and 10 inclusive is the sum of the areas of the rectangles between 5 and 10 inclusive. If we extend this problem and look at the probability that X is any real number between 5 and 10, in other words, if we go from discrete to continuous, then we would take the limit as delta x sub I goes to 0 of the sum of all the f of x sub i's times the delta x sub i's, which becomes an integral from 5 to 10 of f of x dx, where f of x is the function that fits the frequency data and x is a continuous random variable. The definition: f of x is a probability density function if a is less than or equal to b, and if I find the area underneath that curve, I get the sum of all the probabilities, which is what? 1. Measures of central tendency for a continuous random variable. So basically here, I'm integrating. Everyone remember how to integrate? The expected value of x on the interval from a to b is the integral from a to b of x times f of x dx. That is the mean. That is the expected value when you have a continuous probability distribution. Continuous probability distribution. The variance is there. The integral from a to b of x minus the expected value, quantity squared, times f of x dx. The median of x is the value x equals c, such that c is between a and b, and the integral from a to c of f of x dx is 1/2. That would be the median, right? 50% of the probability is below, 50% of the probability is above. And the mode is the value such that f of c is the absolute maximum of the function, if I graph the function. And that makes sense, right? Okay. So you can extend the concept of continuous probability density functions to establish that that ugly function right there is called the continuous probability density function that fits a normally distributed variable and therefore is referred to as the normal density function. Other continuous probability distributions are the Poisson distribution, chi-squared, which we haven't talked about. All right, so sample. A continuous random variable x has probability density function f of x equals to that between 0 and 1 and 0 elsewhere. Find the expected value. Well, the expected value between 0 and 1, I anti-differentiate. Well, actually, I don't have you anti-differentiating on the left-hand side. Method 1 is to just find the calculator numerical integral on your calculator, and you get 0.411. That is the mean. Got it? Okay, the area under the curve. Method 2 is if I don't have a calculator, I have to anti-differentiate and use U substitution and then power rule, and you get 2 over pi times ln of 2. All right, sample 2. My probability density function is k x squared on the interval from 0 to 2. Show that k is equal to 3/2. How do I do that? If I go from 0 to 2 under this function, what must I get? 1, 100%, right? It's the sum of all the probabilities. All right? So I anti-differentiate kx cubed over 3 from 0 to 2 is equal to 1. That's 8/3 k is equal to 1 because 0 over 3 is 0. I realize I'm going fast, but I'm sorry. I want to finish. Do we get this? And k is equal to 3/8. In order for that area to be 100% between 0 and 2, make this a continuous density function, that k has to be 3/8. All right? B, calculate the expected value and the median. Well, what is the expected value? What's the formula I gave you for expected value? This guy right here?
Mean times the
Well, no. The expected value is x times f of x. So it's going to be x times 3/8 x squared, right? From 0 to 2. Because the area under that curve is the probability. When you want the mean, you got to multiply all the x's by the probability, right? Do we understand that, Grant?
Yeah, you don't know the value for x yet. You just put an x in.
X is any of the values between 0 and 2. Okay? I'm looking for the mean.
Yeah.
So now this is 3/8 0 to 2 integral 3/8 x cubed dx. So that's going to be 3x to the 4th over 32 from 0 to 2. And that's 3 times 4, but 4 goes into 32 8 times. Yes? Wait, no, 2 to the 4th is 16. 16 goes into 32 twice, so 3/2 is my mean. 1.5. And don't forget your mean better be between 0 and 2. Right? Because those are the values that you're looking at. All right, the median must be a number such that the integral from 0 to m under 3/8 x squared is equal to 1/2. Right, because the median is going to be where half the data. All right, and that ends up being the cube root of 4. Yep.
Let's say that like finding k was really hard and you weren't able to find k. Would you just like
Make something
make
up.
something up?
Yeah. Make something up. Okay. That is it. So what you're going to do for homework? Yeah, thank you. I'm clapping for all of us.
You did it.
I can't believe everyone's gone for this momentous day. All right, so for homework, you're going to do those last 2 assignments. The probability density functions, discrete, and then the continuous probability density function. All right. Next week, we'll have some time to go over these assignments, go over the practice test, and we'll be on our way.
So we're just gonna like review for the next week.
Well, you're taking an actual practice test for the IB exam, and then we're going to be grading it together, and then you're going to be starting to take all these different tests. So we begin our review. Take a look at the calendar when you get a chance. All right, you guys have a great weekend.
Yeah.